Welcome to Fortify Unplugged. My name's Brent Jenkins, and today we're going to be talking about what is a SQL injection. SQL injection is one of the top web application security risks, and it sits on top of the OWASP top 10. Injection flaws can be introduced whenever an untrusted data source is sent to an interpreter. How it works is attackers inject code into the user input, tricking the query interpreter into executing malicious commands. To showcase how that works, I'm going to pass it over to Lucas Stockhausen, who is going to show a simplified version of what a SQL injection would look like. Over to you, Lucas.
Hi, my name is Lucas von Stockhausen, and I'm Product Manager and Application Security Strategist for Fortify. Today I would like to give you an overview of how we can hack applications and why application security is so important. If we talk about application security, we have to understand that we talk about code, about source code. So if you look at a classical application, you might find some constructs of source code which are looking like this. You have an username which is read from the authenticated user, and that is actually something where this could become an issue, but that's more of a joke. So you look at the user who has been logged in. This name is stored in the variable username, and then you have an item, in this case item name, which is coming from a request, meaning from a URL or from a web form which is entered. And you see here that you use these parameters in order to run an SQL statement. So you say select star from the table items, where the owner is equals the username, meaning the authenticated user, and the item name is equal to this parameter you get from the URL or from the web form. And then you run this query against the database. Well, a normal enter would be, for example, you enter something like my username here could be Lucas, and an item name here could be 10, could be everything. And if I enter that, and this is what the developers normally test, everything works fine. But just imagine I would enter something like this here, right? We have a username of Lucas, and we have an item name of X or 1 equals 1. Well, as we know, 1 equals 1 is always true, and the only thing you have to understand here is a little bit of SQL, understanding that an AND is stronger binding than an OR, meaning the AND condition is evaluated first, and that a semicolon will end every SQL statement. And the dash behind here will actually be a comment. So if we enter that stuff in here, we get something like this right now. Select star from items where owner equals Lucas and item name equals X or 1 equals 1. And then we end the SQL statement and put everything else in comment. If we execute this one, well, just to make it more obvious, we have here select star from items where owner equals Lucas and item name equals X or 1 equals 1. That actually allows us to see the full result, in this case, of the table items. So let me show that to you. We have an application here which I actually host on my own machine. I have a VMware here. If we look at that one, this is where I host this application. So this is how I actually can, how I'm allowed to run scans against this application. So if we log in here as Gary, we can actually see that we have the possibility in order to search through the application and see what I have been ordering as Gary. You see here there are 4 different items. What could be interesting is the in case here we have a clear text credit card number, which obviously would violate PCI DSS immediately, and we have account names or usernames, which very often nowadays are as emails, and with that one, for a competitor, it would be super interesting to potentially go to all these users and ask them if they do not want to get some stuff from the competitive store. So what we see here is I can enter as well a quantity, for example, of 10. So I'm able to manipulate the data which is brought back by the application in order to filter it to only the data I want to see. The question is, if I'm going to enter something like this here right now, just a quote, I get an error message. And this error message, actually, everybody of us has seen already. We are perfectly trained just to click the back button and try it again. Something has gone wrong. But actually, in this page here, we find a ton of interesting information, right? We, for example, see that I'm running this on a completely outdated version of Tomcat. So that's a security risk by its own. We actually see here the quantity and the quote at the end. So this is probably the quote I just entered into the UI. And we see here a complete SQL statement, which is very similar to the SQL statement I just had on my slide. So let's explore that further. If we click back here, just to make clear, the application is still running, right? That's not a thing. But if we enter right now our quote or 1 equals 1 and the semicolon and the dash dash, if we run that one, we get very easily the complete table back here. Meaning we have the results of all users brought back, something we should never have gotten access to. This is truly a simple possibility of an SQL injection, but these things, potentially a little bit more elaborate, are still in the systems. We still see SQL injections in almost all bigger hacks being part of it, and as you know, all these bigger hacks are happening constantly. So this is something where a firewall, just a normal firewall, will never protect you from, because this is actually happening on the application level.
Awesome. Thanks so much, Lucas. So now that we've taken a look at how a SQL injection works and what it looks like, how do we stop it? We've summarized a few bullets for your consideration. Use prepared statements. Utilize stored procedures. Leverage whitelist input validation. Escape all user-supplied input. And use frameworks that have built-in injection protection. To further those points, let's take a brief look at how we at Fortify can help you. If you're a developer, Fortify detects injection flaws and provides type-specific remediation advice. If you're in QA or operations, Fortify validates code at runtime for mitigating controls. And if you're in operations, Fortify provides runtime logging and protection for Java and .NET injection attempts. Fortify application security testing protects your entire software development lifecycle with the most automated, integrated, enterprise-scale on-premise and cloud solutions. Companies build their software around the Fortify experience, expertise, and leadership. And once again, for the 6th year in a row, Gartner has recognized Fortify as a leader in the application security testing Magic Quadrant due to our strong execution and constant innovation. Thanks so much for joining us. Make sure to like and subscribe to our channel and leave us a comment and let us know what you thought about this video. Have a great day.